Time travel. The concept has fascinated humanity for centuries, capturing our collective imagination and inspiring countless stories, theories, and dreams. The very phrase sparks our imagination. It conjures images of mysterious machines, wormholes, and the possibility of altering the fabric of reality itself. It hints at a world beyond our everyday experience, a world where the boundaries of time are not fixed, but fluid, allowing us to traverse the past, present, and future at will. We dream of journeying to the past, witnessing historical events firsthand, or leaping into the future to see what lies ahead. The allure of time travel is universal, transcending cultures and generations. From H.G. Wells's iconic The Time Machine, which introduced the concept of a vehicle that could travel through time, to the adventures of Marty McFly in Back to the Future, where a DeLorean car becomes a time machine, time travel has captivated audiences for generations. These stories have become cultural touchstones, influencing not just literature and film, but also our understanding of science and technology. It offers a tantalizing escape from the present, a chance to rewrite history or glimpse what tomorrow holds. The idea that we could change our past mistakes or see the future's advancements is both thrilling and thought-provoking. Science fiction writers have woven intricate tales around time travel, exploring its paradoxes and possibilities. They delve into the complexities of time loops, alternate realities, and the consequences of altering the timeline. But could this staple of science fiction one day become science fact? Theoretical physicists and scientists have pondered this question, examining the laws of physics and the nature of the universe. Let's embark on a journey through the realms of science and imagination to explore the tantalizing question, is time travel possible? We will delve into the theories proposed by renowned scientists, the technological advancements that bring us closer to this dream, and the ethical dilemmas that time travel presents. Albert Einstein's theory of relativity opened the door to the possibility of time travel. According to his equations, time is not a constant but a variable that can be affected by speed and gravity. This led to the concept of wormholes, theoretical passages through space-time that could connect distant points in time and space. While wormholes remain hypothetical, advancements in technology and our understanding of the universe continue to push the boundaries of what we believe is possible. Virtual reality and simulations allow us to experience different times and places, offering a glimpse into what time travel might feel like. However, the prospect of time travel also raises significant ethical questions. If we could travel back in time, should we? What responsibilities would we have to the past and future? Could altering one event have unforeseen consequences on the timeline? As we continue to explore these questions, time travel remains a powerful tool for storytelling and a source of endless fascination. It challenges us to think beyond the present moment and consider the vast possibilities that lie within the fabric of time itself. Whether through the pages of a book, the scenes of a movie, or the theories of science, time travel invites us to dream, to wonder, and to explore the infinite possibilities of our universe. The journey through time is not just a journey through history, but a journey through our hopes, fears, and aspirations for the future. Before we delve into the science of time travel, we must first grapple with the elusive nature of time itself. What exactly is time? Is it merely a construct of the human mind, a way to measure the sequence of events, or is it something more profound, woven into the very fabric of the universe? Time has puzzled philosophers, scientists, and thinkers for centuries. We often take it for granted, yet it governs every aspect of our lives. From the moment we wake up to the time we go to bed, our days are structured around the ticking of the clock. But what is this mysterious force that seems to flow endlessly forward? Is it a constant ticking away at a steady pace for everyone, everywhere, or does it vary, influenced by factors we are only beginning to understand? The synchronized clocks in different cities around the world suggest a universal time, but is this truly the case, or is it more fluid, a river with currents that ebb and flow? Just as a river can have calm stretches and turbulent rapids, could time also have its own variations, speeding up and slowing down depending on the circumstances? Our everyday experience suggests that time is linear, a straight line from past to present to future. We live our lives in a sequence, one moment following another in an unbroken chain. But is this perception of time an accurate reflection of reality, or merely an illusion created by our limited senses? The concept of a linear timeline is deeply ingrained in our culture. We mark the passage of time with calendars and clocks, celebrating milestones and anniversaries. But what if this straight line is just a simplified model, a way for our minds to make sense of a more complex phenomenon? But Albert Einstein, the revolutionary physicist, challenged this notion. He proposed that time is not absolute but relative, intertwined with space to form a four-dimensional fabric called space-time. This idea was a radical departure from the classical view of time as a constant, unchanging backdrop to the events of the universe. He proposed that time is not absolute but relative, intertwined with space to form a four-dimensional fabric called space-time. This means that time can stretch and compress, depending on the speed at which an object is moving and the strength of the gravitational field it is in. This phenomenon, known as time dilation, has been confirmed by numerous experiments and observations. Imagine a grid representing space and time, a four-dimensional fabric that can be stretched and warped by the presence of massive objects. This grid is not static but dynamic, constantly changing in response to the movements and interactions of everything within it. Imagine a trampoline as a representation of space-time. When you place an object on the trampoline, it creates a dip, curving the fabric around it. The heavier the object, the deeper the dip. This is a simple analogy for how massive objects like planets and stars warp the fabric of space-time. A bowling ball placed in the center would create a dip, curving the fabric around it. Smaller objects placed on the trampoline would roll towards the bowling ball, not because they are attracted to it directly, but because the fabric of the trampoline itself is curved. This is similar to how gravity works in Einstein's theory of general relativity. This, Einstein argued, is what massive objects like planets and stars do to space-time. They warp it, creating curves and dips that affect the motion of other objects. This warping of space-time is what we experience as gravity. It's not a force pulling objects together, but rather the curvature of space-time guiding their paths. They warp it, and this warping is what we experience as gravity. This revolutionary idea has profound implications for our understanding of the universe. It suggests that time and space are not separate entities but are interconnected, and that the fabric of space-time is constantly being shaped and reshaped by the presence and movement of matter and energy. This concept opens up new possibilities for exploring the nature of reality and the potential for time travel. Einstein's theory of relativity introduced groundbreaking concepts that revolutionized our understanding of time. One of these mind-bending concepts is time dilation. Time dilation suggests that time is not experienced the same way by everyone. It proposes that time can speed up or slow down depending on your relative motion and the strength of the gravitational field you're in. Imagine two synchronized clocks. One remains on Earth while the other embarks on a high-speed journey through space. According to Einstein, the clock traveling at high speed will tick slower than the stationary clock on Earth. This phenomenon, though seemingly bizarre, has been experimentally verified. Atomic clocks flown at high speeds in airplanes have shown slight but measurable time differences compared to their Earth-bound counterparts. If we could somehow manipulate space-time, could we create shortcuts, tunnels through this cosmic fabric connecting distant points in space and time? This idea has fascinated scientists and science fiction enthusiasts alike for decades. The notion that we could bypass the vast distances of the universe and travel instantaneously from one point to another is both thrilling and mind-boggling. This is where the concept of wormholes enters the picture. Wormholes are theoretical passages through space-time that could create such shortcuts. They're often depicted in science fiction as gateways that allow for rapid travel across the cosmos. Wormholes, also known as Einstein-Rosen bridges, are hypothetical tunnels that bridge two different points in space-time. These fascinating structures were first proposed by Albert Einstein and Nathan Rosen in 1935 as part of their work on general relativity. Imagine folding a piece of paper in half and poking a hole through it. This simple analogy helps to visualize how a wormhole might function. The paper represents the fabric of space-time, and the hole acts as a shortcut, connecting two distant points on the paper. The hole acts as a shortcut, connecting two distant points on the paper. In theory, a traveler could enter the wormhole at one point and emerge at the other, bypassing the space in between. While wormholes are theoretically possible within the framework of Einstein's equations, their existence remains purely hypothetical. The mathematics of general relativity allows for the possibility of these exotic structures, but we have yet to find any empirical evidence that they exist in our universe. Even if wormholes do exist, traversing them presents enormous challenges. The stability of a wormhole is a major concern. They are thought to be incredibly unstable and might collapse before anything could pass through them. They are thought to be incredibly unstable and might require exotic matter with negative mass energy density to hold them open, a concept that remains entirely theoretical. Exotic matter is a hypothetical form of matter that has properties opposite to those of normal matter, and its existence has not been confirmed. The idea of using exotic matter to stabilize a wormhole is intriguing but highly speculative. Scientists have proposed various theories about how such matter might be created or discovered, but these ideas remain in the realm of theoretical physics. If we were ever able to create or discover a stable wormhole, it would revolutionize space travel. The ability to traverse vast distances in the blink of an eye would open up new possibilities for exploration and colonization of distant worlds. Imagine being able to travel to another galaxy in a matter of seconds, or visiting a distant star system without the need for long-duration space missions. The implications for humanity would be profound, potentially allowing us to become a truly interstellar species. In addition to spatial shortcuts, wormholes could also theoretically allow for time travel. By connecting different points in time, a wormhole could enable a traveler to move backward or forward in time, raising fascinating questions about the nature of causality and the possibility of altering the past or future. However, the concept of time travel through wormholes introduces a host of paradoxes and challenges. The famous grandfather paradox, for example, questions what would happen if a time traveler were to prevent their own grandfather from meeting their grandmother, thus preventing the traveler's own existence. Despite these challenges, the study of wormholes continues to be a vibrant area of research in theoretical physics. Scientists are constantly exploring new ideas and pushing the boundaries of our understanding of the universe. While we may not yet have the technology or understanding to create or traverse wormholes, the pursuit of this knowledge drives innovation and inspires us to dream of what might one day be possible. The quest to unlock the secrets of space-time and discover shortcuts through the cosmos is a testament to humanity's unending curiosity and desire to explore the unknown.